Hi, my name is Nishant Chandran and I am a researcher at Microsoft Research India. I will be teaching you the number theory part of this course on discrete mathematics. The first question one might ask is, why study number theory? There are several reasons. Firstly, I think it's a lot of fun. It's fascinating to explore the world of numbers, and in fact, the great mathematician Carl Friedrich Gauss is said to have remarked, mathematics is the queen of the sciences and number theory is the queen of mathematics. It was earlier thought that number theory had absolutely no application, but it turned out that people were completely wrong. Today, every banking transaction on the internet uses number theory. So I think that's a fascinating reason why we should all study number theory. So let's just get right into it. Okay, so let's start with some elementary facts about number theory. This is something that you may have seen during your high school education as well. And we will talk about divisibility of integers. So to just get started with some formalism, we define what it means to say that a number A divides B, or that B is a multiple of A. They both mean the same thing. So the definition is, let A and B be two integers, and this font Z will denote the set of all integers. And we say that A divides B, or that B is a multiple of A, if there exists an integer k such that b is equal to k times a. For example, we say that 4 divides 84, 17 divides 714, but 13 does not divide 300. Some elementary facts about integers are the following. If a divides b and b divides c, then a divides c. If a divides b and a divides c, then a divides b plus c. If a divides b and b divides a, then either a equal to b or a equal to minus b. If a divides b, then a divides bc as well. If a divides b and a divides c, then a divides xb plus yc for all integers x and y. I will just prove the first statement over here and leave the rest as an exercise for you. So we have that a divides b and b divides c. What does this mean? This means that there exists an integer k1 such that b is equal to k1 times a. And also there exists an integer k2 such that c is equal to k2 times b. Now, from these two statements, what does it mean? It means that c is equal to k2 times k1 times a. But that just means that k2, k1 is an integer such that c is equal to k2, k1 times a. And that just means that a divides c, proving the first statement. I leave it as an exercise for you to verify the remaining statements that have been listed here. We shall now define quotients and remainders. Again, this is something that you may have seen in your earlier classes. So formally, let a be an integer and d be a positive integer. Then there exists unique integers q and r such that a equal to q times d plus r, with r lying between 0 and d, 0 included. We say that q is the quotient denoted by q equal to a div d, and r is called the remainder denoted by r equal to a mod d. Let us prove this statement, and the proof will be by contradiction. The first step is, let q be the largest integer such that qd is less than equal to a. Now, let r is equal to a minus qd. Since we know that q is the largest such integer, we know that 0 less than equal to r less than d, right? Now, the only thing we need to show is uniqueness. That is, there must not exist some other pair Q prime R prime such that A is equal to Q prime D plus R prime with 0 less than equal to R prime less than D. So in order to show uniqueness, we will show the proof by contradiction. What does that mean? We will assume that there exists another pair Q prime R prime such that A is equal to Q prime D plus R prime. What happens in this case? In this case, this means that Q prime D plus R prime is equal to QD plus R as well, because we just said A was equal to QD plus R. Right? This implies that Q prime minus Q times D is equal to R prime minus R, or that D divides R prime minus R. However, we know that R and R prime both lie between 0 and D, 0 included. Right? And from this, we have that R prime minus R must lie between negative D minus 1 and positive D minus 1, both included. The final step is that we remark that the only number divisible by D between minus D minus 1 and D minus 1 is 0 itself, because there's no number greater than equal to D within this range. And this means that R prime minus R must be equal to 0, or in other words, R prime equal to R. And from the equation that Q prime D plus R prime equal to QD plus R, this gives us that Q prime equal to Q as well. We will end today's lecture with some fun facts about divisibility. For example, if I want to check that a number is divisible by 2, all I need to do is check if the last digit of that number is divisible by 2. Another thing I need to do is, if I want to check that a number is divisible by 7, here's what I do. I remove the last digit from the number. So let's work through this example. I have 5971 over here. I remove the last digit from this number. What do I get? I get 597. I multiply the removed digit by 2 and subtract this from the truncated original number. Right? So the removed digit was 1, and I multiplied by 2 to get 2, and I subtract to get 595. Okay? I repeat this procedure. Okay? So now I take 5 multiplied by 2, that's 10. And I subtract it from 59. And I get 49, which is a multiple of 7. It's 7 times 7. And if that happens, I rule that 5971 is divisible by 7. Now, why do these tests work? It seems like a very strange, odd test. But during this course, we will see why some of these tests actually do work.